So, you want to learn how to program in Unity? Well, you've come to the right place. Welcome to my first lesson in my Unity crash course. Within this crash course, I'll be going over programming basics to try and help you guys learn to read and write code better. Note, I am not a professional. I just graduated from my university for computer science, so I know how to program well, but I've never taught people how to program. I will try my best to teach you guys how to do things and program within Unity. Things I say might not be the best way to do things, and sometimes I may get some stuff wrong. If I do, please just let me know and I will try to correct my errors. In this lesson, we'll be going over components, which include game objects, the transform component, other components, and then creating your own component scripts. We'll be going over mono behavior, and then scripting with variables, function calls, loops, and component references. At the end of this lesson, there will be a quiz that will have problems for you guys to solve. Once you get to these, please read over the question and then answer it to the best of your ability before I display the answer. Don't forget to subscribe and hit that bell for notifications. Let's get started. Components are the main idea behind creating games in Unity. To create a game in Unity, it's very important that you understand what components are and how to utilize them to their fullest. Components hold data, interact with each other, call functions, etc. They basically define what the object is going to do and be used for. A game object is the base of all objects in a scene. It holds its own special values, like whether it's active in a scene, the name, layer, tag, etc. You can think of it as its own component that every object will always have. Another component that every object is forced to have is a transform component. This tells the engine where to place and face the object and how large it should be. A transform component holds the position, rotation, and scale of an object in the scene. Accessing this and adjusting the position and rotation is one way you can move objects in the scene. It also holds other stuff like its parent. To be parented means the transform goes into local mode and the position, rotation, and scale are all referenced locally based on the parent. This means that any movement to the parent also moves all the children. Children of an object are the objects parented to it. There is more to the transform, but for now we can leave it at that. You can add components to any game object. Some of the pre-made game objects come with specific components. Any primitive object like a cube, cylinder, or sphere, they come with a mesh filter, mesh renderer, and a collider. Each one of those are components. A renderer will render a mesh in the scene. A collider will add a physics bound that can be used to block collision and such. Components are truly the backbone of the Unity engine. And when you're first programming in Unity, you're actually creating components. We can see this. Let us create a quick script that we'll be using for this lesson. We can call it whatever you want. I'll be calling it lesson 1. The basic outline for your code will already inherit from the mono behavior class, and that is what actually makes your script a component. It'll even show up in the component search menu if you type in the name of your script. When you make a script, you must make sure you add it to an object like any of these other components, otherwise it will not run. So let us add our new script as a component onto an object before moving on. There, now let's go over the mono behavior functions that are normally used to program components. So open the script you made earlier by double clicking it in the assets folder, and you'll see that you'll have a class name and then a colon and then mono behavior. First, know that your class name must be the same as the file name. You can rename them, just make sure they are the same as each other. Next, understand that the colon mono behavior means that this class is inheriting from the mono behavior class. Inheritance is an important topic that we will go over in another video. Just know for now that this means that it is deriving fields and methods from mono behavior, and that it's actually what makes this script a component. This is also why you can use the functions of start, update, fixed update, awake, onEnable, etc. These functions are only called at the right times because they are being derived from the MonoBehavior class. If we remove this, then none of these functions will call when we play our game. Speaking of functions, let us go over them. Start is the function that is called right before the first update. If the object isn't active, then it will be called when it's activated. It is used mostly to call functions and run code at the start of runtime. Update is simply called every single frame while your game is running and the object is active. It is mostly used to run code continuously during runtime. Fixed update is called every fixed physics frame. It follows a fixed time step that you can edit and see under Edit, Settings, Time, and then Fixed Time Step. I do not recommend changing that unless you need to. The default value is 0.02. That means fixed update is called every 0.02 seconds, which is 50 times in 1 second. No matter the frame rate you are getting in your game, fixed update will always be called every 0.02 seconds. That is why it's popular for movement, because it's not dependent on the frame rate that you are getting. Awake is called when the component is loaded before the start function. It will still be called if the component is disabled as long as the object that the component is connected to is enabled. If both object and component are disabled, then it will be called whenever the object is enabled. OnEnable is called every time the object and component are both enabled or re-enabled. If the object and component are already enabled on startup of runtime, the function will call before the start function. Note, all these functions are case sensitive, and if you do not write the names correctly, they will not be called. It is important to understand when to call your functions to start writing code and putting code or function calls in the correct base function. After understanding MonoBehaviors, the next thing we should do is start going over scripting topics such as variables, function calls, loops, and component references. All of those are topics that are important when creating your own component scripts like we will be doing. So let's get started. Variables are data holders that hold specific types of data. They can be referenced and manipulated to help out while programming. You declare the type, as in float, int, vector3, etc., and then the name. You should name it using camel case, which is a naming scheme where the first word of your variable is all lowercase, and then any word after that has the first letter capital. Some examples are this max health, player controller, bullet damage. Every first word of the variable is lowercase, and then the next word has the first letter capital. You also can declare a modifier to a variable such as public, private, protected, static, etc. In my programming practice, I believe there are 3 sections of variables used for programming components in Unity. They can easily be differentiated in how you write them. The 3 sections are customizable, state, and data variables, with some exceptions. Customizable variables are variables that are edited and changed within the inspector that will adjust how the component runs and the other variables' data. They are the properties for the component that will help define it. They will not be changed during runtime or be adjusted by code, and these can be written in 2 ways with a clear difference. If the variable will need to be accessed by other components when you reference the class, then add the public modifier to the variable. If not, then the private modifier should be added to the variable with an attribute of serialized field above it. That will make it visible and editable in the inspector, but will not allow it to be accessed. It is important to keep unnecessary variables and functions from being public. It helps remove clutter and confusion later down the line. State variables are variables that help describe and understand the current goal for the component. These are adjusted purely by code and dictate what the current status of the component is. They are always written with a private modifier as to not be accessible or visible in the inspector. If you would need to access this state variable, which may need to happen, then you can do so using a property. A property is a combination of both a variable and a function, with two methods of get and set. Using this, you can control what happens when you get or set the state variable. This is actually best explained with an example. So here we have a player health script I created. At the top you can see the customizable variable max health with a default value of 100, and you can see that it is a private serialized field. This is because we don't want it accessible by other functions, but we want it visible in the inspector. So if we go there and drag this onto an object, you can see that we can adjust and see max health. Next, you can see we have the state variable current health. This will just keep track of what health the player is currently at. But I do need this to be accessible publicly. That way the player can be damaged. So here you can see that it has a get and set, just like we talked about. And so the get here must return the same type of data the property is, which is a float. So we're just going to return our private float variable current health. Next, you can see the set has a value parameter, and it's equal to whatever is inputted into this property. You can see current health equals 10 means the value is 10. You also see I set previous health to current health. That just keeps track of what the current health was at before we set it. So if we go down to the update function here, you can see that I have current health minus equals 10. And what this is basically doing is it's actually calling both get and set. So it gets the current health, and then it subtracts it by 10 and sets current health to that value. And once it's set, it also sets previous health as I described earlier. I'm using debug here to showcase the current and previous health. Once we play, you can see that when I hit H, I'm going to see that update. So you can see current health, previous health. And as I hit H, they both decrease, showcasing the change of the current health and previous health. The last variable section is data variables. They are used to store information for the state variables, and they are there for speed and convenience. Basically, everything else other than customizable and state variables can be data variables. These can be written with either the private modifier or with no modifier at all if you want to easily differentiate them from state variables. From the player health script we just went over, previous health is a data variable because it is used with the state variable current health. Understanding the difference of these variables is important to create your own component scripts and having your code clean and organized. Calling functions is the next important topic that needs to be covered before you start creating your own component scripts. We went over the important functions that are included from inheriting mono behavior, and those will be used to call our functions. Writing our own functions is like writing variables with some different conventions. A function has a return type, name, and parameters. A basic function that will not be returning any data has the type being void. Void means nothing is returned, so returning just ends the functions and you don't return anything in that return statement. You can change void to a type that will be returned like int, float, vector3, etc. Note that if you do so, your return statement must have a value with that type, otherwise you will get errors. Names give an overview of what your function will do and should be written with each word being capitalized. Parameters are special arguments in functions that are set when calling the functions and provide data that can be used within that function. They are optional and will not be needed for every function, but they are helpful in recursion calls and functions that will need to be called multiple times with different sets of data. They can be any type of variable that can be either set as a constant value or set using a variable of the same type. You can call functions from within another function, and if your function returns a type, then you can set a variable to equal that function and it will be set to whatever is returned. When calling a function, the function you are calling is completed before continuing the function that you called it from. It is important when programming to understand how to loop and when to loop. Looping will allow programmers to run code multiple times. You can loop through data and run code on each individual set of data. They are commonly used to traverse an array to access each index, but can be used to compute algorithms, generate data, etc. I will go over the popular types of loops and show you how to utilize each one and give examples. For loops are the most common, so let's start with them. The for loop statement consists of two mandatory statements, the initializer and the condition. It then has an optional iterator. The initializer statement is called right before the loop begins and normally will initialize an integer counter named I to any number, but most commonly 0. The condition is a Boolean expression that is checked before each loop. If it is false, then the loop will end without running the code, but if it's true, then the loop will run the code in the body. The iterator is optional, but it is a statement that is called after each loop. After all the code in the body runs, it will be called. Normally, this is used to increment the initialized counter to make a step closer to making the condition false and ending the loop. If your condition never turns false, then the loop will go on infinitely. You can also write a for loop with no condition to have the loop run infinitely too. Just note that an infinite loop can crash your game and the Unity engine. You can loop a specific number of times with these simple examples of for loops. The left will run from I is equal to 0 all the way up to 9, so 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and stop when I is equal to 10, which is 10 loops of the code in the body. The right will run from I equal to 1 all the way up to 25, and stop when I is equal to 26, which is 25 loops of the code in the body. Using for loops, you can easily traverse an array and get each index and value from it. You can use your initializer to initialize an integer to keep track of your current index and start it equal to 0, since array indexes start at 0, not 1. Then the condition statement will make sure that you stay in the bounds of the array using its length. I has to be less than the length because it starts at 0, so the indexes of the array are from 0 to the length minus 1. Then you can use the iterator to increment the I variable, which is the current index, to access the next value in the array. In this example, I access each value and add it to a string, then add a comma and a space as long as it is not the last index in the array. It makes a nice string of the array contents as seen in the output. For loops can get more complicated as you start calling functions within the loop's statement. In this example, you see that I call two functions in my for loop statement. The first is the generate data function using people and rooms as the parameters, and this is my initializer. So this is called right before the loop runs, and what it does is it basically picks random amount for both people and rooms. Then you can see my condition also calls a function called extra people, and what that does is extra people just calculates how many people will not be in a room if the rooms are split evenly. And so what this for loop does is it runs as long as there's extra people. So as long as there's people not in a room, then what we should do is run the code inside. And you can see there isn't any except for people minus minus, which is decrementing people by 1. And basically what this is just an example that your iterator can also be placed inside the body. And if you want it to run the same as a normal for loop, you can just put it at the very end. but it can go anywhere in the body of the for loop. Next is the for each loop. The for each loop is a simple loop used to loop through sets of data like arrays and lists. It will go through each item in the array or list and set the variable to reference that item. This is easier to read and handle because it needs only a variable of a type and an array or list of the same type. So you might think, why would anybody use the for loop when the for each does the same thing and is both easier to read and understand? Well, little viewer, you will sometimes have to use the for loop instead if knowing which index you are currently at is a priority, or if you need to change how you move through the array while in the loop. If you're doing anything more complicated than that, I recommend a for loop instead. It is great for accessing collections of classes and modifying and using their data, as seen in this example. I am accessing each person class in the array people, then posting their information using the class's public function person info. The while loop is next, and this loop is easy to understand as it will just loop the code within the body while the statement within the parenthesis is true. So it's important to make adjustments towards making that statement false, otherwise it will loop forever and crash Unity. This is very similar to the do while loop. Instead, the do while loop runs once right away, and then it loops as long as the statement is true. So even if the statement for the while loop is false, the code will run at least once before looping. That's what sets it apart from the while loop. An example of the difference between these two loops can be seen here. The loop is the same in both, with I being divided by 10 and then increasing the count. After the loops run, however, you can see that the while loop doesn't run at all, since the Boolean expression right away is false. But the do while loop runs twice. This is because it runs once right away, as all do while loops will, but then after running once, the statement is now true, so it runs again, and then after that, it's back to false. So it actually runs twice while the while loop doesn't run at all. Those are the basic loops and how they are written, and some uses for each. Understanding looping is important for creating your own component scripts in Unity. Accessing and using other components is the last topic that we'll be going over today. When creating your own component scripts, you will most likely need to access other components or scripts as well. First, understand that the monoBehavior component has references to the current game object that it's on and the transform connected to it. You can easily access these by just typing gameObject or transform. You can see the example here. We can access and store the position that this gameObject's transform is currently at. Then we can call a public rotate function that the transform component has to rotate this object. You can access any public variable and functions of both the transform component and gameObject. Every component, even your component scripts, have a function called getComponent, which will allow you to get any component that is on the same object. The most popular way is to call this from the gameObject reference, as you can see in this example, but it can be called on its own, or from a transform, or really any component. At the bottom here, you can see an example of storing a variable of the rigid body component on this object and then accessing it later to call functions. Using this, you can interact and connect any of your component scripts together as long as they are on the same object. In another lesson, we will go over the other ways of accessing scripts, but for now, this is where we'll keep it. Now, let's create our first script with our newly learned knowledge. Alright, so for the script, I decided to make a script that drags rigid bodies around. So you can see we have 3 rigid bodies all in different shapes. We have the sphere, cube, and cylinder here. And what I'm going to be doing is dragging it to the mouse cursor. And so we're going to be sending a raycast out through the mouse cursor onto the ground here, the blue ground. So we need the rigid bodies on their own layer so we don't hit them, we only hit the ground. So you can see each of these are on the layer objects. And then the plane here is just on the default layer, which is totally fine as long as it's not the same layer as the objects here. So we're going to make sure that our lesson 1 script we created earlier is just not on anything, otherwise we're going to get errors. So there, it's not on anything, and what we're going to do is we're going to drag it to our main camera. You can see our main camera now has the lesson 1 component on it. And we're going to open it up and see what we can do. So first things first, we need to get our customizable variables. So we're going to do that now, customizable variables. So I kind of thought this out already. What we're going to need is a serialized private rigid body, which will be what we drag around. So drag a body around. And then we're going to have another one. And these are all going to be serialized private because we're not going to be accessing this with another script. So if we were going to need to access them, we'd always can make them public. This one, we're going to need the ground layer mask. So it's going to be a private layer mask, ground layer. Next, we're going to need a private vector3, and this is going to be the drag offset. And then finally, one final one, which will be the speed. We're going to name drag speed. And we're going to default this value to 8. So right away, if we go back in, you can see that we have them all here, and we're going to start setting them. The ground layer is on default, so we're going to make it that, and then the first thing we're going to do is drag the sphere around. You can see we have a drag offset, which we're just going to keep at 0 for the sphere. It's really only used for the cylinder and cube, mostly because the cube here, if we apply force directly at its position, it won't move very well, unless we set like no friction as a physics material, but I don't want to do that. So instead what we have is this drag offset. And so if we increase the Y, then the force will be applied higher up on the cubes, away from its like center of gravity, and so it will roll better. The sphere does not need an offset, hence why it's 0, mostly because it's spherical. So it rolls around just fine. Let's go back to the script. So we're going to need a couple of state variables that will help us understand what we should be doing right now. So we're going to need a vector3 goal position, where we're going to want the body to be dragged to, and then the private float body distance, which is the distance from the rigid body to the goal. This will just be the goal. Next, we have a couple of data variables that are just going to be used to store some information. First, we need the direction that we're going to be rolling, which will be a vector3, and then a camera component that will be used to basically find the goal position. So in start, let us get that component. So since we put this on the camera, the main camera, which has the camera component, all we need to do is get the component camera. This can also be written as camera equals game object dot get component camera, but the game object is optional really, since we're going to have it on the same object anyway. So in our update here, we're going to be doing a couple of things, but first we're going to need to make sure that everything is set. So if we don't have a body right now, so if we don't have anything inputted, it means it's null, which means we can't do anything, or our camera is null, which means we don't have a camera component on this object. Then what we're going to do is we're just going to return right there. So what this does is it ends the function if the above statement is true. Because it's a void function, which means we don't need to return any value, we can just end it right there just using return. But if this is false, so if we do have a body that dragging and we have a camera component, then it'll move on and we can set the goal position equal to our goal, which for now we're going to keep vector3 0. But what we're actually going to do is we're going to use a function call to set it. So we're going to get goal position right here, and we're just going to use a data variable goal, set it equal to 0 quick. And then we're going to actually set goal position to this function instead of 0. And you can see it's giving us an error. That's because not all of our paths return a value, because we need to return a vector3. So we're just going to return the goal. So next, what we're going to do is we're going to calculate this out. So first we need an array from our camera that is using our mouse position. So the camera that we get actually has a function already, which is screen point to ray, which returns a ray going from the camera through a point on your screen. And so we're going to need to use that. And then the point from the screen will be our mouse position, which you can access directly from the input class. So now we have our from camera and we have to actually use that. Let's write out what this does. It gets an array from the camera at the current mouse position using the screen point. Then what we're going to do is send a raycast out using the ray from the camera to hit the ground to get a goal point. So if our physics.raycast using our from camera ray hits something, so out variable hit, using with a distance of 100, basically just that's just the distance of the ray. We're just going to set it to 100 because it's such a big value, and then but we only want to hit the ground layer. And so if we hit this, because this returns true if we hit something. So if we hit something on the ground layer, what we want to do is we want to set goal to wherever we hit, which is hit point. And then the last thing we need to do is we need to remove the y value. This is because we don't want to be adding vertical movement. And then return our goal. And so you can see here, if we don't hit anything, as like if our mouse is off of the window, or if we're just, our mouse is over like the sky instead of the plane, then we're just going to go back to vector3 0. If you want to basically not have it and just have it stop there, what you can do is you can just set goal position directly, and what it'll do is, or like we can just set this equal to goal position and then default goal position here to 0. And that way, if we're hitting something, then it'll go to the last position. But if you want it to just circle back into the center, then we can just set it to vector3 0. So there is that. So now we're getting our position using our mouse point on the screen. And so what we need to do now is we need to basically roll towards that point. So we're going to set roll direction equal to our goal position minus our drag body around position. So what this is doing is it's determining, like it's grabbing the position, or it's grabbing the vector between the goal and the rigid body. But you can see we apply 0 y. So if we are in the air, or if we're above y, which we will be, we need to adjust for that. So we're going to do no y position, which will be our position, but then we're just going to set y equals to 0. You can also write this as new vector 3, drag body around position x, 0, drag body around position z. That works too. And so we're going to use the no y position to get our direction. So right now this is giving us our vector between the rigid body and the goal. And so the distance, our body distance, is actually the magnitude of this vector. This is because it's between the 2 points, and so the length of that vector is actually the distance. So let's add some comments here. So remove the y from the rigid body position. Get the vector between the goal and the rigid body. And then body distance here. We're going to grab the magnitude of the above vector, which is actually the distance. Next, we have our roll direction. We need to normalize it, which basically it just returns the vector with a clamp with a magnitude of 1. What that does is we have to do the body distance before we normalize it. Otherwise, body distance will always be 1, which is not what we want. And so just make sure you get the distance first and then normalize the direction. Next, we're going to need another data variable. Also, this is a data variable. Our no position y is a data variable. The next one here is what we're going to do is the multiplicative force that will be applied to the rigid body. So we're just going to call it force, and it's going to be a float value, and we're going to default it to the speed here. But if our body distance is less than or equal to 1, we're going to actually multiply that force by the body distance. This lowers the force applied if we are close to the goal position. But since we're applying force, rigid bodies, like especially the sphere, will just keep rolling, and so it'll kind of like go back and forth across the goal. So what we need to do is we need to slow the velocity down when the body is close to the position. So what we're going to do is we're going to access our velocity of the rigid body. We're going to set it equal to the lerped value of this velocity to our roll direction, which you can see is normalized. So we're going to times that by our drag speed. Oh, sorry, not drag speed. That's my bad. We're body distance. That way we can actually it's force. I do believe it's force is the best way to do it. So we were close. We went from drag speed to body distance to force. Slow understanding the math, but I do believe that is correct. And then we're just going to lerp it by our drag speed times the delta time. And then the last thing we need to do is we actually need to move it around normally, which will just be drag body around, add force. We're actually going to do add force at position because we have that offset, drag offset. So we're going to do the roll direction times our delta time times the force. And then we're going to do our drag body around dot position plus the drag offset. with using the force mode impulse, just like that. So what we're actually going to do is we're going to take this and we're going to put it in its own function, which will be void move or drag body, just like that. And then we're going to call this in the update function, like so. And then we can see when we go into here, just double check that we have everything set correctly and hit play, and let's see what it looks like. So you can see it drags it right to my mouse, just like that. So let's see if we can knock this cylinder down. Boop, slam, just like that. So this is working pretty well. So that's what I want. So there we go. So we can see here, if we apply to the cube and try to do the same thing with the offset 0, 0, you can kind of see it kind of work. Boop. But it's slow and it's not as responsive as the sphere. So if we just increase this just by like a little bit and then hit play, we'll see the difference. So you can see it moves even better now. And if we do it even more, we should flop around even better. Yeah, there we go. Just like that. Look at that. Cube moves too. Same with the cylinder. Boop, boop. Cylinder moves a lot better when it's on its side like this, but then it can't go up and down. But just like that. So that's just a brief review using everything we've learned. But what I want to do is I want to drag them all around. So I'm going to change this to a array and then check to make sure that it actually has things in it. So if it's less than or equal to 0, we're going to end the function. But if it's not, then we're going to call it. So you can see our drag body, we have a bunch of errors. So what we're actually going to do is we're going to add a parameter of the rigid body and call it drag body around. So now what all we have to do, as you can see now we have an error because we don't have the parameter inside of it. What we're going to do is we're going to loop, use the initializer here to create a index counter, use that index counter and count all the way up to the array's length and I++, and then we're going to drag the body using the rigid body at that index. So now we should be able to drag an array of them. So right now it's at 0. If we add 2, let's drag the sphere and the cube around. So if we hit play, they should both move. Yep, now they're both moving towards the point here. You can see that. And if we want, we can even control all 3. Oop. Now all 3 of them are coming. Just like that. All right. And just like that, you can see how we've used everything we learned today to kind of create a nice, simple, and clean component that moves rigid bodies to our mouse position. The next thing that we're going to be doing today is our pop quiz. So just know that you can pause the video whenever, if you need to, but just answer them to the best of your ability. I just hope that the quiz kind of just helps hammer in the knowledge into your brain just a little bit better, just in case my explanation of the different variables and the example here didn't quite do that just yet. So anyway, let's get started. What component is the base for all objects in your scene? Game object, transform, renderer, or mesh filter? Game objects are the base for all objects in your scene. What components are always on any object in a scene? Game object and mesh filter, transform and mesh filter, game object and transform, collider and rigid body. Game objects are the base for all objects in your scene, and the transform tells the engine where and how to render them. These two components are always on every object in the scene no matter what. Which of these components are not already on a primitive object? Game object, mesh renderer, transform, or rigid body? A rigid body is a component you can add onto an object, but it is not one that already comes on a primitive object. The ones that are already on it are a game object, transform, mesh filter, mesh renderer, and a collider. Which monobehavior function is called at a constant rate? Fixed update, start, update, or awake? Fixed update is called every physics frame, which is at a constant rate. Which monobehavior function is called when the component is loaded? Awake, start, on enable, or fixed update? Awake is called when the component is loaded, if the object that the component is attached to is enabled. Which monobehavior function is called even when the component is disabled? Awake, start, on enable, or fixed update? Awake is called even if the component script is disabled as long as the object is enabled. Which monobehavior function is called every frame? Fixed update, start, update, or awake? This is just the definition for the update function. Which of these are not a section of variables in my practice? Data, customizable, serialized, or state? Serialized is not a section of variables in my practice, it is a property of a variable in a class. Which data variable is written correctly? Data variables are used to store information for state variables and are always private. Note that the first answer has incorrect naming because it doesn't follow camel case naming convention. And the last one is serialized, so it would be public in the inspector, which we do not want for data variables. Which customizable variable is written correctly to not be accessible when referencing the class? A serialized private field is what we want for a customizable variable that will not be accessible when referencing the class. The last answer is a serialized public field, which doesn't really make sense because public fields are already serialized within the Unity inspector. And a public field is accessible when referencing a class, so it is not the correct answer and neither is the third. Which is a valid function? Void is case sensitive, so the second one does not work. It is also okay to return no value when using a void function, unlike the vector3 function. Since it has a type, it also needs to return a value of the same type, which the last one does not. The second is invalid due to the number in the name. Numbers cannot be the first character in the name of a function. Which of these cannot be a parameter? Void, int, vector3, or float? Void is a function-only type and cannot be a parameter. Which part of the for loop is called after each loop? The condition, initializer, body, or iterator? The iterator is the section of the for loop statement that is after both the initializer and the condition, which runs after each loop. Which part of the for loop is optional? Condition, initializer, body, iterator? The iterator is optional and does not need to be in the for loop statement. Which loop always runs at least once? While, for, do while, or for each? Do while runs the code at least once. That is what differs it from just the while loop. Which of these is an invalid way to get a component from the current object? Object is not a valid class, and you cannot access the get component function from it. The other answers are all valid. So how did you guys do on the quiz?
Big brain time.
There's a total of 16 questions, so you could get 16 out of 16 for 100%. Anyway, I hope that helped you guys understand a bit more of the topics that we went over today. And that is actually it for what I have for this lesson. It got super long, and I'm sorry it took so long to make, but it's just so long. It was a lot to edit and put together and write out what I was going to say and everything.
Impressive.
So, anyway, I hope you guys enjoyed. If you did, please like, subscribe, hit that bell. You know what to do. And I will be continuing this series as well as making more tutorials. So I really would appreciate you guys subbing if you guys are watching this. And if you stuck around this far, a big thank you. Watching the whole video helps a bunch. And I'll see you guys in the next video.